Hey everyone, welcome to Homeschool ICSE, and we are with the first chapter of class 10 chemistry, periodic table, periodic properties and their variations. We have already discussed till ionization enthalpy. If you have not yet watched, video links are provided in the description. Don't forget to watch. And today I am with two important periodic properties. One is electron gain enthalpy. The other one is electronegativity. See, most of you feel that both are similar, but no, they are very much different. Okay, so the difference between electron gain enthalpy and electronegativity is what I am going to tell you in today's class. So the first concept, electron gain enthalpy. So it's a very important concept even for competitive examinations for NEET and JEE that you are going to write after your 12th. Okay, so electron gain enthalpy. And it is also called with the name electron affinity. So here electron gain enthalpy and electron affinity is one and the same, right? So in short, we can call it as EA. See guys, this is exactly opposite to ionization enthalpy. So what was ionization enthalpy? It was energy required to remove outermost electron, right, from neutral gaseous atom. So in the same way, these non-metals, okay, have a tendency to accept the electron. So where will the incoming electron go? It will go and settle in outermost shell, right? So when the electron is coming and getting settled in outermost shell, energy is released. Energy is actually released. Say, I'll tell you one beautiful concept here. Try to understand. Say you have an atom fluorine. So what is its electronic configuration? 2, 7. Isn't it? Okay. See here, fluorine is not stable because in its outermost shell you have 7 electrons. When it can become stable? When it has 8 electrons. Right? So fluorine happily accepts 1 electron. Okay, so when it accepts 1 electron, okay, this is the symbol for electron actually. So on accepting 1 electron, it will become F minus. So what is the electronic configuration of F minus? It is 2, 8 and this is the most stable electronic configuration, right? And you know what? Whenever, okay, let me draw a shells around fluorine's nucleus. So this is the nucleus of fluorine and it has 2 shells. So in the first shell you have 2 electrons. In the second shell already 7 electrons are there, right? 4, 5, 6, 7. Okay, so now that 8th electron is coming and it has to settle here, right? See here, this electron is very much essential for fluorine because on getting 1 electron, it is achieving stability, isn't it? So the atom is very much happy. The atom is very much happy to accept an electron. And you know what? This electron can happily settle here because there is very less distance between this shell and nucleus. So nucleus can show its attraction towards this electron also, right? So the atom is very much happy to accept that electron and it will show its happiness by the release of energy. Okay, so in this situation what happens? Energy is released. So this released energy is what we call electron affinity or electron gain enthalpy. Okay, so whenever the atoms accept electron with lots of happiness, you know what, to show their happiness, they will show their happiness with the release of energy. So this way you can remember the topic in a easiest way. Fine. So you understood now the main concept of electron gain enthalpy, right? So now let me write the definition for you all. The energy released, the energy released when an electron is added to neutral gaseous atom is called electron gain enthalpy. Okay, so whenever energy is released, that energy is indicated with a negative sign. Okay, say for example here F is there. On accepting one electron, it has converted into F minus, and during this process energy is released. Energy means what here? Heat. Okay, so heat is released. Okay, so how much of heat is released? Almost around 298 kilojoule per mole. Okay, per mole, this much amount of energy is released. Actually, this is the unit. This is the unit of electron gain enthalpy. Okay, and you see here I will show with a sign, negative sign. What do you mean by this negative sign? This negative sign tells that this is the released energy. Okay, say this negative sign tells that energy is released. Energy is released. You know what? Ionization energy you studied. There, you have to provide energy to an atom to remove the electron, right? So, you are supplying energy from outside. So, that ionization enthalpy values, no, you will observe with positive value. Okay, so they will have positive value. Here the energy values are negative. Negative value indicates that the energy is released. Positive value indicates that the energy is supplied. Okay, so in which case you will observe energy is supplied? In case of ionization potential, energy you need to supply from outside to remove an electron, right? So those energies are indicated with a positive sign, and electron gain enthalpy energies are indicated with negative sign. Okay, so this is all about electron gain enthalpy. And now, like every other property, your electron gain enthalpy also depends on two factors. Depends on two factors. Okay, so what are the two factors here? First one is atomic size. Atomic size. You know what? As atomic size increases, our electron gain enthalpy decreases. Okay, what I wanted to tell you is, smaller the atom, the incoming electron will feel more acceptance, right? Say for example, whenever you go to your relative's house for the holidays, you will stay there only when they accept you, only when they love you, or only when they care you, right? Say same thing here. Say this electron, the outsider electron, will stay in the outermost shell only when it is accepted by the nucleus. When does the nucleus can accept this outsider electron? When the distance is very less, when the distance between outermost shell and nucleus is very less, right? If the electron is present somewhere very far from nucleus, and how can it show its affection, right? Say for example, if you want to get your relatives affection and love, you should stay near to them, right? You should not stay away from them, right? When you stay near to them, they will understand you and they'll value you and they'll love you. Just like that, if the electron is very much near to the nucleus, it can accept, right? So that's why smaller the size of an atom, more will be the acceptance for outsider electron. So when electron is nicely accepted by the nucleus, and the electron is very much happy, and that happiness is shown by the atom with the release of much high energy. Okay, so if the atom is more happier, more energy is released. When do an atom can feel more happier? When outsider electron is accepted very nicely by the nucleus. So when outsider electron can be accepted very nicely by the nucleus when the distance is very less. Distance between outermost shell and nucleus is very less. Okay, because this electron can stay only in the outermost shell. It cannot go to inner shells. Okay, so that's why smaller the atom, more will be the electron gain enthalpy. So what do I write here is electron gain enthalpy is inversely proportional to size of an atom or atomic size. Okay, atomic radii. So just this one relation will tell you everything, right? Okay, so similarly electron gain enthalpy can also depend on another factor, that is nuclear charge. Okay, so more the nuclear charge, more would be the attraction, right? So definitely our nuclear charge is directly proportional to electron gain enthalpy, right? So this is how our electron gain enthalpy depends on both atomic size and nuclear charge. And now let me talk about the trend in electron gain enthalpy. So when you go across the period in the sense when you go from left to right, size of an atom decreases. If smaller the size of an atom, more is electron gain enthalpy, isn't it? So definitely electron gain enthalpy increases, okay, when you go across a period, that is from left to right. And similarly down the group. So when you go from top to bottom in a group, our size will increase. So definitely the outsider electron is present somewhere very far from the nucleus, and that guy will not get enough attraction from nucleus, isn't it? So our electron gain enthalpy decreases, right? Okay, so among all elements in the periodic table, your halogens, that is our 17th group elements. Can you all name the 17th group elements? Fluorine, chlorine, bromine and iodine. So these guys have highest electron gain enthalpy. Okay, clear everyone? So because they are smallest in size and they have a nice ability to accept an electron, and the accepted electron will happily stay in the outermost electron, and that electron is very much necessary for fluorine to complete its octet, I mean to achieve stable electronic configuration. So atom feels more happy and it releases more amount of energy. So more amount of energy released means highest electron gain enthalpy, right? So this is a very important point. 17th group elements have the highest electron gain enthalpy. Okay, and then first group elements. What are the first group elements? Lithium, sodium, potassium, rubidium, cesium. So these guys have the least electron gain enthalpy. This is very important point. So why do they have least electron gain enthalpy? Because they are bigger in size. So even if outsider electron is added to them, you know what? It's very far away, and the atom is not happy to accept an electron. For example, I'll tell you. Sodium is there, right? So sodium atomic number is 11. So what is its electronic configuration? 2, 8, 1. Okay, so can you all expect that it will accept one electron? So on accepting an electron, you know what? It will not attain a stability, right? On accepting an electron, imagine if it becomes Na-1, its electronic configuration is 2, 8, 2. It's not stable. It's not stable. So this process will never occur. So, sodium achieves stability by losing electrons. Say if it can lose one electron and if it can become 2, 8, then, it achieves stability, right? So, it achieves stability by losing. It will not achieve stability by gaining. So, sodium is not happier to gain that electron. It's not at all happy. Even if you forcibly put the electron, it says, no, I don't want this electron. It is disturbing me much more. It says that. Okay, so that's why it's less happy to accept the electron. So I said all these guys, not only the sodium, lithium, potassium, rubidium, all of them have least electron gain enthalpy. They are not happy to accept an electron. Okay, if they are not happy, means not energy is released when you put the electron into a outermost shell. Clear? So this is the concept of electron gain enthalpy. Okay, and again one more point, try to remember. See here, among fluorine and chlorine, chlorine will have highest electron gain enthalpy than fluorine. Okay, we know that fluorine is much smaller than chlorine, so fluorine only should have more electron gain enthalpy, but it is opposite. Chlorine will have more electron gain enthalpy. It's because, you know what, fluorine shell already has 7 electrons. Okay, and it's a small shell. Second shell is a small shell. Already it is filled with 7 electrons, and the 8th electron, and it can stay in the shell, but these electrons, the old electrons, will fight with the new electron. It says that we only do not have a place here, you have come, you just get lost. That inter-electronic repulsions you will observe between old guys and the new guy. Okay, so that again makes the fluorine atom to become unstable. Fluorine is happy to accept an electron, no doubt. One electron is necessary to achieve stability. But since the second shell is smaller in size, the fighting between electrons takes place. Okay, so that's what we call inter-electronic repulsion. Whereas chlorine is much bigger atom, right? Say the outermost shell for chlorine is third shell. Third shell is much more bigger. Says, how do you arrange 7 electrons? 1, 2, 3, 4, 5, 6, 7. There's nice space, and the 8th electron can stay here with less repulsions because it's a bigger shell. Third shell is much bigger shell. Along with the 7 electrons, 8th electron also has much space. Okay, much place to stay inside. Compared to the second shell, third shell is much bigger. Okay, so here less fighting between electrons you will observe. But in the second shell, since the shell itself is small, already 7 are there, you will observe more fighting between the new electron and the old electrons. Okay, so that is the reason, adding electron to chlorine is more easier, right, compared to fluorine. So that's why we say high electron gain enthalpy is shown by chlorine, not fluorine. So this is very, very important point for competitive examinations actually. Clear? So that's all about your electron gain enthalpy. And now let me talk about electronegativity, which is a last property that you are studying in a chapter. See guys, there is lot of difference between electron gain enthalpy and electronegativity. Say electronegativity means it is the ability of an atom to pull the electron pair. Which electron pair? Bonded pair of electrons. To pull the bonded pair of electrons towards itself is called electronegativity. Okay, this particular concept is observed in molecules and compounds which have chemical bonds. Okay, especially when they have covalent bond. For example, if you take a molecule of HCl, okay, say HCl, and this bond is called covalent bond. Hydrogen's electron is there here, chlorine's electrons is there. Both have shared with, both electrons got shared between them, and that is staying as a bond, which we call it as a covalent bond. Okay, and here this chlorine has a capacity to pull both electrons towards itself. Actually, bond means 2 electrons. One electron is from hydrogen, the other electron is from chlorine. But chlorine has that greedy nature. Okay, so it has that selfish nature. It wants both electrons to be present more towards itself. Okay, so chlorine has a ability to pull the bonded electrons towards itself. Exactly, they should be present at the center, but what actually happens, since chlorine takes the electrons towards itself, these two electrons are present more towards chlorine. Okay, so such an ability of an atom is called electronegativity. Okay, see, what is electron gain enthalpy? Energy released when you add electron to the outermost shell. But here you don't find any release of energy or gain of energy. It's not anything about energy. Okay, say here no heat is liberated and we don't supply any heat. Energy in the sense heat, right? So here it is just a property of an element or some atom to be able to pull the bonded electrons towards itself. It is just a property. Okay, it's nothing to do with any energy. So that's all about electronegativity. Okay, and this electronegativity also depends on atomic size. It depends on atomic size. Okay, say smaller the size of an atom, more easily it can pull the electrons towards itself. Smaller guys are always more active, isn't it? So smaller atom can pull, can grab the electrons more towards itself. So that's why, you know what, atomic size, you know, how does it vary with electronegativity? I can say electronegativity is inversely proportional to what? Atomic size. Atomic size. Okay, so this is a very important relation one must understand. So based on this atomic size, I can always talk about the trend in electronegativity. Trend in electronegativity. Okay, say that means across a period, when I move from left to right, that is across a period, what will happen for electronegativity? See, across a period from left to right, the size actually decreases. If size decreases, electronegativity increases. Right? So smaller atoms are always more active. Say, okay, next point, down the group. So down the group, what can happen here? So what do you observe when you go from top to bottom here? The electronegativity decreases, isn't it? Why? Because atomic size will increase from top to bottom. Right? Fine. And you know, one point try to remember, halogens, that is our 17th group elements, fluorine, chlorine, bromine and iodine. So these elements are the smallest in size among all the elements in the periodic table, and they are highly electronegative. So they are highly electronegative compared to all other elements. And again, among fluorine, chlorine, bromine, iodine, fluorine is the most electronegative element in the entire periodic table. Okay, so among all 120 elements in a periodic table, fluorine is the most electronegative element. Whereas in case of electron gain enthalpy, it is chlorine that is more, which has got more electron gain enthalpy. Right? So there is lot of difference between electron gain enthalpy as well as electronegativity. Right? So electronegativity is a property of some atom to be able to pull the bonded electrons towards itself. Right? Whereas electron gain enthalpy is the energy released, heat released when an electron is added to outermost shell. Okay, so that's all about the various periodic properties that you have in your syllabus. So we discussed about atomic size, metallic character, non-metallic character, chemical reactivity, ionization energy, then electron gain enthalpy as well as electronegativity. Okay, so with this, the major topic of the chapter is over. I can say almost the chapter is completed, right? So with this, I am completing this chapter, and very soon I will meet you all with the next chapter. Okay, next interesting chapter. Thank you so much. Hope the information has given you enough benefit. And if you want any other topic to be told in a detailed way, you can just post in a comment box. We will try to do the topic in a detailed way. Thank you so much.